Hello everybody, and welcome back to another lesson. Today, we're going to be continuing with our pipes. This lesson, we're going to do the zigzag pattern again, except vertically over here, instead of horizontally like this. Or I guess you could say that this is horizontal, and I guess you could say this is vertical, because it's up and down, this is horizontal, but yeah, it's just the other direction. So we're gonna be building the pipe so that it goes out, up, and then extends right into the steam boiler. So yeah, let's start that. So first, let's build an exit elbow. So this going out, and all we need is to use the geometry.cylinder. Geometry.cylinder. I think we're gonna find up in geometry helpers class. I call this feed pipe elbow out. So the size so pipe radius is the radius, elbow length is the length. Outside X, elbow, mid Y, so the location runs the outside X. Oops. Oh, now it's upside down. Okay, so outside X. So over here, elbow, mid Y, so also mid of this axis. So if you look, it'll define approximately like over here for the pipe, and run Z. Well, it's the same height as that one, which at the end of the for loop. Whoops. And since at the end of the for loop runs use this top, and rotation 90 radians, because remember what I said last lesson, that if it's horizontal you want it to rotate at 90 radians on the x-axis. And then let's append this exit elbow. I need a list, and I forgot a comma, but that's okay. And oh look, I actually put that in the for loop. Okay, I did it on purpose, by the way. There you go, now it's like for the top one. Alright, next with a better pipe that goes up. Final top Z, the steam object start location, that's just plus 0.2. You can experiment with shade system, but if you want it to be higher or lower, but I think that's ideal. And then run bottom Z, because the pipe we're making starts from the bottom here up, so obviously the bottom will be the Z for that. So which means it's at the midpoint of this pipe. The length is top Z minus bottom Z, and I need to put an underscore over here. So obviously this would be the vertical length, top minus bottom, and then mid, obviously, because define them using the mid. You take the average. bottom Z 2.0. Oh, I forgot. You need to use geometry.cylinder. For the X and Y, it's the same as some other variables we defined up here. It's only the Z that needs changing. That's why we have the. So let's name it feed pipe final vertical. The size, the self, so the radius of itself. The final length we defined up there. Outside X, outside Y, so we define Y, and then we use the final mid we define up there. And then rotation. It's vertical, so you don't need to use any rotations, it's all 0. Segments, final vertical, append that, and there we go. Now we have our final do the pipe steam drum. So we want over, up, and then back in. So yeah, okay. Final height Z is, so the final top Z of that. The top of that, well, is just the Z for everything. Final horizontal. What did I say? H was height earlier. It's horizontal. Steam object dot location dot Y. It's the same Y. Final H length is outside Y minus final HY left. So outside. So this is outside Y minus final HY. Length to get the whole length. No, this is outside Y minus HY length. Okay. To get the whole length. Final mid Y. Final HY left. Plus outside Y. So you take the average. Divide by 2. Feed in is geometry. Or use the cylinder thing we defined earlier. Feed pipe in self dot pipe radius final H length outside X final mid Y final HZ, and then rotation it's horizontal, so 90 radians, and append the whole process for our things. Now it's time. So basically for our vertical runs here, we're gonna have up and then inside, and then we're gonna have a for loop for everything. So first let's define the variable. This runs to count is 4. So I can change that. We're gonna put this into a formula so that the spacing is always going to be good. Then slight closer to chamber and slightly shorter ground start. So slightly shorter compared to this, and slightly closer to the chamber. So this is where we're gonna put this. The pipes that lead into the vertical pipe run zigzag pattern thing. And I have to delete that slash. Now I'm outside. Y2 is center y plus half dy plus 0.5. Ground z2 is just bottom z because the ground is always the ground, so they should share the same thing. Entry z2 is bottom z plus 0.2. So top bottom, no, short vertical outside segment. So we have some of the variables. No, we can make some. Let's do a bit more, and we can do it. So length is entry z2, right? Minus ground z2, because the entry is up there, the ground is down here, so the length would be that minus that. v2 mid is ground z2 plus entry z2 y2. So take the average, and that's enough. Segments v out 2, geometry dot cylinder v2 vert outside, self dot pipe radius v2 length, center x outside y2 v2 mid. I'm just saying other variables. Rotation, no variable. I mean no rotation. So I mean the radius of itself is pipe. The length is, we already defined it, and we use everything over here using the things we used up there. And rotation we could set manually because it's theoretical. It's always going to be 0. Now if up, down, we need to go left. Elbow into chamber. So elbow to left, y is the right plate dot location dot y times 0.9. So if we look at it from this position, elbow to left, y would be this position, like the distance between these. Wait, I forgot to append the segments to append seg v out 2. Entry z2. Okay. So basically it's the distance from this right to there times 0.9, so it's slightly smaller. So you can see it is indeed over there. So it goes slightly in. Because if you compare the distance from here slightly in to here to here, you'll be able to see it. Actually, no, you don't compare it like this. They don't have anything to do with each other. Sorry, elbow 2, the length, the absolute value of outside, y2 minus elbow 2 left y. Just in case there's like a negative number, we want the absolute value. So outside y2 minus elbow left, elbow 2 mid y is outside y2 plus elbow 2 left y divided by 2. Oh, nothing happened because I didn't put anything, but so just take the out, you get the mid, and then you can dot cylinder, geometry dot cylinder, feed to elbow in self dot pipe radius elbow 2 length center x elbow 2 mid y entry is e2, so the radius is self, the length we defined is the length, and then the size. Now this is the location of the size we also defined earlier, and then it's horizontal, so we rotate it on the x-axis by 90 radians. Then segments that append that. Now we can do the fun runs. We need to find it up here. Runs to count. We can go usable z2. There's self, so the height, a quarter of the height. Runs to bottom is the entry, but slightly taller than the entry. So which makes sense because it was on, it would look kind of weird. Run, so the length is just usable z2. Run top c, so the top of the runs. You take the bottom plus the usable. Oh, it runs top C, not the usable, the length, because it's rotated, so the length is actually that, and then the usable is that. Span y is self, so what it spans, how much it spans, so self dot width times 0.6, so it's slightly above 0.6. Run y start 2 is center y minus span y divided by 2. Run y and 2 is center y plus span y. So we're just getting the averages. We'll start on the end because they differ. Run x2. Only the y value changes, and the z, but not the z. Only the y value changes here. The x doesn't really change. Now y positions. So this will come in handy later, and you'll see for I and range runs to count. We want to find the amount of times we have. Y position is run y start 2 plus I. I'll write down the formula and then I will explain it. Run y start 2, then divide that by, not 2, runs to count minus 1. So obviously the y position equals, you know that this would take the y position. How does it do that? So first, the end 2 minus start 2, so you take the end position, and then subtract the start position. That'll get you like the length, I think, right? So then divide that by the runs 2 count minus 1, because you want to be able to get the length of like one of those little runs, and minus 1 is how you do it. But in case you want to get the y value, and that's like the y length, I guess. Not really, but you can imagine like that to explain it better. For length for 1, starting from the y position, but starting from the y position to each one of the y positions different, because, well, we have one horizontal pipe over here. The length from this to that is different from another one over here, this to that. So that's why I need the I times that, and run when I start to is just the starting position, so it doesn't go randomly. Y positions dot append y position. So you put these into the list. Then you have this one z mid runs to bottom plus run z length divided by 2.0. So it's just taking the average again. Oh, I need parentheses. Run. Then we can use the geometry dot cylinder. Feed to run. And then this is to make sure there are always 2 digits, so if it's 1, it's 1.0 instead of just 1. The radius is itself. The length is the thing we defined earlier. Next to y position run mid z. No, this needs to be an underscore. Rotation is 0, 0, 0. I added too many parentheses. Segments append. Alright. Oh. I forgot to close this curly bracket. Where is this? Runs. Is it runs E2? Oh. It's runs bottom, not with an S. There we go. Look at this. It looks good. Now it's time for the horizontal connector things up here to make the zigzag pattern. For I in range, and actually it's not runs count, it's runs count minus 1 because one of them doesn't need it. And for the horizontal connectors, you need you have 2 y values, right? YA and YB. This is y positions I, y positions I plus 1, because we got all the y positions for these, so you get this one, and then you get the y position of the next pipe over, so that's why you get the next one, right? And then so on, get this one, that one, this one, that one. YA, YB, YA, YB. Conductor length is the absolute value of YB minus YA. Connector mid Y, but it's the mid, so we just take the average. Alright, now let's alternate, so up, down, up, down. So how we're going to do it is if I is divisible by 2, so that this is how you do it. Modulus 2 if it's equal to 0, so remainder 0, which means it's divisible by 0. Connector Z is run top Z, which we defined. If it's not, then connector Z, so the Z value is runs to bottom. So it's the bottom. And now let's do this. Obviously you need to have the F string again. I02D. Self.pipe radius, connector length. I will explain what those mean. Run x2, connector mid y, so everything we defined earlier. And the connector Z, so which would alternate. And it is horizontal, right? You already know what we want to do with, like, how we want to rotate it. Finally, append, and we're done. No, we're not, because something is wrong with the code. Okay, it's fixed. I don't know what happened. I couldn't find anything. Maybe Blender is just being weird, but yes, the things are back to normal. Yeah, and I'll see you next time. Bye.